All right, so after a hiatus of a couple days, we're going to try and finish this problem because I hope some people are now paying attention where others are not because they decided to not show up because they're too cool for school. Okay, so when we were doing this a couple days ago, we're trying to maximize the area here. And I know the minimum area with these four sides of these fencing is going to give me 9 meters squared. Okay? And then if I do it in a rectangular form, which was this one down here, it was 18 meters squared. So the only way that we could actually try to adjust this is if I did this with my shape. Instead of actually having, for those people there, okay, instead of actually having this piece straight, we actually made it to like a little house shape right here. So we're trying to actually see if there's a way that I could actually make this become a larger area than my 18 meters squared. Right? That's what I'm trying to do. So I went through, we found for some values. Okay. I think our biggest issue was actually just trying to figure out the height of the triangle. Biggest issue was trying to find the height here. Because I need to find two different areas, two distinct different areas. So area 1 was 3 times y, and area 2 came out to be all of this right here.
I don't know who this is.
Okay. Area 2 was this piece right here. So we went through and tried and find a value for h where it was going to be in terms of y. Because that's the variable right here that I'm trying to find out for. Okay, I'm trying to find that value. So if I find that value, then it's going to be able to maximize an area out of this. So I came up with this because it was here. That's the area of the triangle on the top. That was the area of the triangle on the top. So it's 1/2 y times h. So this is just this piece up here. Okay, my y value is the base, and the h is something I was having to find. But since I don't have a lot of that information, I just took the area, the basic area formula, and solved for the h. Because I don't want an h in a formula over here where I have two different variables. I only wanted the y value. So if I figure out the y value, I could eventually go back in to figure out what the h would be in this specific case. That's what I was trying to get to. So, long process, long process. I got the derivative up to this point right here. So I plugged it all in, I got the derivative, I came up to this right here, and then as we were going, okay, so if you're watching the video, you're just pausing it, or if you're here, you're actually looking at the notes that you already have. So I carried it over, I found common denominator, I put them together, and I came up with, when it was equal to 0, right, I set it equal to 0, right here, okay, set it equal to 0 here, so I got my, but now before I could do that, I took my denominator equals 0 because a critical point is not just where my derivative is equal to 0, it's also where my derivative is undefined. So my derivative, so once I took the denominator right here equals 0, that was going to be undefined. So where that is undefined, I went through and solved for it, and I came out with y is equal to plus or minus 6. Going back to my original function, I'm paging back over, I started off by saying that y had to be between 0 and 6. Because 6 is the largest. I can't make it any further this way. Can't make it any further in this direction here than 6. And this right here would be my 0 because I took this and actually shrank excuse me. I shrank my y value down to its 0, where it's just going to be boxed out here. So when it is 0, it is 9. When it's 6, it was 18. So I have those two values already. So I just need to find a min or max in between here. So my derivative, where it's undefined, was plus or minus 0. And we said that's going to be outside of my realm because I'm not using those. Now, we got to this point right here. So I have my derivative. I set it equal to 0. I was able to cancel out my entire denominator by multiplying it by 0. That's where I'm at now. I'm left with this piece right here because when I set this equal to 0, this cancels out. So I'm left with only the numerator. Yes?
So those are our asymptotes then?
Yes, this would be not really asymptotes. Asymptotes goes with my original function. But this isn't the original function, this is the derivative. This would be a critical point. This is where I cannot take a derivative of my function. So the function is still continuous. If it was discontinuous, not continuous, then my original function would have this right here. I would have plus or minus 6, so that would be an asymptote. But because this is where I cannot take a derivative, that means that this is going to be a cusp. Okay, it's going to be a cusp. It's a place in which that the derivative does not exist. Okay, I can find a value of it, but not the derivative. Okay, pointy points. Now I'm over here. Okay, I'm over to this point over here. So now I'm trying to set my derivative equals 0 because I'm going to get a value out of this. So let's take a look what I have right here. So if I combining terms, I'm left with 0 equals 24 parentheses 9 minus y squared to the 1/2 plus 35 minus y squared. Okay, so we got to try and figure out how to get this. So we're trying to solve for it now, right? So let's take a look. I'm going to have to try and factor it out somehow. Okay, yes?
Where'd the over 4 go?
Where'd the over...
Like the y squared over 4.
Y squared over 4. Oh, you're right. I missed that. Over 4. Thank you. Just trying to go too quick. I think my head was in the way when I was copying it.
Oh,
Yes.
can't you just distribute the 1/2 so it'd be 3 minus
You can't distribute a 1/2.
y?
But what I can do is I could try to get rid of that. So let's start by isolating my y's on the right hand side and put the other numbers on the left hand side. Okay? To do that, okay, I'm going to have, let's see, it's going to be negative 35 equals 24 9 minus y squared over 4 1/2 minus y squared. Okay, so now let's take a look. This one's not going to work out very good, so I'm going to put the y on the other side also. You'll see why, because I'm trying to isolate the 1/2. I'm trying to get that piece by itself. If I'm able to get that 1/2, this piece by itself, I could square both sides. So if I square both sides, I could actually get rid of the nasty part of this. So, okay, I'm moving that also now. So now it's y squared minus 35 equals 24 quantity 9 minus y squared over 4 to the 1/2. Okay, so let's go ahead. If I square both sides, here, let me move a new page. So we had y squared minus 35 equals 24 quantity of, was it 9?
Yeah.
9 minus to the 1/2. So now, if I'm able to square both sides, I'm able to square both sides. So this is going to become 24 squared, which is, I don't know, it's less than 625? 576. And this is just going to be, when I square this, that goes away. 9 minus y squared over 4 equals, that's going to be y to the 4th minus 70y squared plus 35 squared. I don't know what 35 squared is.
1,225.
One what?
1,225.
Like that? Okay. So, again, I'm trying to isolate. trying to get my y's by itself. So let's go, and I gotta do a distribution here. I gotta do a distribution, so it's gonna be y4 minus 70y squared plus 1225 equals, distribute this, 576 times 9. Wow, it just got quiet. Can anyone want to help me with this one? 5,001.84
Yeah.
minus this divided by 4. Let me see, that's going to be 13, 19, 12, 18. So it is divisible by 4. $576 divided by 4.
1,296.
What?
1,296.
Is it 140? 144?
144? Okay. 144 y squared. It's dividing by 4. I'm sorry. Yeah, dividing by 4 because there's a 4 on the bottom and it is divisible by 4. Do you guys know the trick to figure out if things are divisible?
The last two digits.
No.
I know 1 through 3
If
is if they add up to make like a
The last
factor
two
of 3 or
digits,
Yeah.
something
your
like
last
that.
two digits have to be divisible by 4.
Yeah. So, yeah, just stuff like that.
How do you know if it's divisible by 7?
If you put in the calculator and divide by 7.
Do you want to trick?
There is a rule for it, I just totally forgot.
You want to know the trick is divisible by 4. Then you have to find the prime factor.
Okay, so let's go ahead and move everything to the left. We're moving everything to the left. Everything to the left. So if I move everything to the left, I'm going to have equals 0 now, and then I'm going to have something I could actually factor. So that's going to be y to the 4th. That's going to be plus 74. 74. Seriously, I'm winging it here, so I need some help.
Yes, that makes sense.
Yes? And then minus 51.84. Crap. So 1225 minus 51.84.
Oh my. 9 is the one all the way over there.
What is it?
3,950.
3,000.
959.
There we go.
How does that look
Okay,
Mm-hmm.
now, this is a calculator problem. I have got you to the point where we can actually do the calculator, right?
Yay.
So, we know that this has to be equal to what?
0.
0. And what's going to be the domain for these values?
0 to 6.
0 to 6. 0 to 6, because we stated that at the beginning. So what can I do with this information right now?
You can restrict
Cross
your
out
domain.
0 and 6.
No. Restrict the domain. So can we put in the graph?
Yeah, you can make your window from 0 to 6.
Make the window 0 to 6. And then what am I going to be looking for?
Whatever value.
Zeros, right? So please do that right now. Okay? I know everyone has a calculator right now.
Yeah.
Everyone has a calculator.
Let everyone stuff not.
Instead of learning magic. Not like, but. You get non-existent. We got this far. We stopped here. You kind of screwed me with this one.
All right, my function was x to the 4th plus 74x squared.
Oh, maybe that's why.
Let's see. Minus 3959. 3959, enter.
Not 6.
Yeah, it's not supposed to be 6.
9, 9, 9, 9.
Is it not 6?
It's just turn upside down. It's 5.9, 9, 9, 4.
Damn it.
Oh, it's not 6.
Ooh.
It's barely
Doesn't the
4.
question ask what it if there is bigger?
No, there is going to be, and I don't know if it was continuing the math and missing one of the parts. Let's see if I can do this one then. Yeah, go ahead.
So the max area is more wide.
All right, let's see if I could actually do the same thing here, but start it off with this part, when I just took the derivative. My derivative equal to 0.
Yes.
my derivative equal to 0 right here. So if I do that, my function control divide. So if I do this calculator, it might have actually, if I did the calculator earlier, have saved me some time. Plus 4, 9, minus squared over 4.
They're testing next door. The partners.
Oh, that is different.
Oh, those are.
But not.
I didn't have shoes in the morning. I haven't opened it. Do you need to take minutes?
Alright, I guess I made an error on my math somewhere.
I knew it.
Because from my derivative, I get the same thing. I'm going to hide this piece just so I can see my graph. So I get the same thing with this. It's my derivative. So if I plug in the function, let's try it again, but now this time if I plug in the function that I had, so the area was supposed to be this in terms of the y value. So we have 3x, right? Plus 0.5x parentheses 9 minus x squared over 4 to the 1/2. Point 5 times x Oh, I know why. that is my function. That is my function. I'm trying to find min and max. So let's go with window and 0. Right there. So there's my graph. So my maximum value is supposed to be 19.8. Wow. Do you know what I just showed you guys?
You can just plug it in.
Yeah. So I just wasted 2 days worth of math when you could have just did it in the calculator right away. I know, right?
So we found the area, the derivative of the area, and it'll put it in the
So, yeah, find the area function, put it in the calculator, and you want the maximum. So, the maximum is supposed to be 19.8. So, there's my maximum area,
So you would use 5.58.
which would be which value? My y. So, in this case right there, it would be my y value. So, this right here would be my 5.58. Actually, calculus, we always require 3 decimals.
Wait, what did you just do?
Click on the number and hit control menu, attributes, and it's going to give me more decimals. So the standard in the calculator is either 2 or 3, depending on what settings have been changed on your calculator.
I don't know if it's
All right, so my value for the maximum area should be 19.817. So whenever we're doing this, we always have to have 3 decimal points. So do you know what that means? That means I made a mistake in between the area and the derivative, because my derivative was still wrong, but my area function was correct. So I made a mistake in between there and there. Okay? So when you actually see problems that are calculator stuff, you could use a calculator. A calculator tells you the derivatives. It tells you the mins and maxes. If you want to find a slope at a point, the calculator will do that too. And integration, it will do that. You guys will be super happy about that one later on. Okay. Integration is the antiderivative.
Wait, what?
which means
Okay, so you know when you take the derivative of a function?
Yes.
Okay, so yeah, so
Take the function of the derivative.
okay, so
goes after
yes, no. Okay, what's the opposite of multiplication?
Division.
division.
Okay, so the opposite derivative is antiderivative, or also known as integration. So if I gave you the velocity and I wanted you to find the position, you would do the antiderivative. So you start with position, velocity, acceleration, right? Or if I give you acceleration and want to find the velocity, yeah, that's what you got to do.
So would you do like chain backwards?
Yeah.
How do you even
Oh,
do that?
division, I guess?
All right, so
Just put it-
manufacturer needs to produce a cylindrical container with capacity of 1,000 centimeters cubed. So, and the top and bottom of the container made of material that costs 0.5 cents per square centimeter, while the sides of the container are made of material costing 0.3 cents per square centimeter. Find the dimensions that will minimize the company's cost of producing a container. All right, so a couple things I know. I know that my capacity, my volume, has to be 1,000. So I have two functions here. So I have 1,000 cm cubed. And the volume formula of a cylinder is pi r squared h. So this piece is super important. But after this, what are we maximizing or minimizing?
Surface area.
Surface area. So now I have to have an area formula. And if I'm maximizing or minimizing the area, that means I would do what with that? If you're minimizing an area, what mathematical thing do you have to do to minimize it?
Negative sign.
Morning. So I take the derivative of the area to maximize it, right?
Yes.
Or minimize it. Derivative of the area. Okay. I'm not very accurate this morning. So I'll try again. So my area, my surface area, is going to be my soda can. Okay. Okay. Yeah. It's going to be a soda can, basically. Big soda can. So, think of the soda can. So the top and bottom are what shapes? Circles, right? So I have two of those, don't I?
Yes.
So it's going to be 2 times, what's the area? Pi r squared. Very good. Now, the side or lateral area of the side of it, so I'm going to draw so you guys could actually see this. It is going to be a rectangle.
You need the circumference, right?
Yes, very good. So the circumference has to wrap around the circle, right?
This is diameter
I
times
know it could. Something.
times something.
Okay, so what is this right here? This of my can would be the height. Very good. So that's the height. And the circumference of a circle, it's just normally pi times diameter. But we don't want diameter. We want radius, right?
So pi times
2.
Pi r.
Yeah, there we go. 2 pi r. Okay? So, that's important. So, that's going to be a 2 pi r. Okay, so plus 2 pi r h. Yeah?
Yes.
Okay, good. So, all right, we're trying to maximize this, right? So, what don't I like here? I don't like h. Very good. So, what am I going to do to get rid of that?
You substitute the 1,000 for V, right?
I'm going to do what? I'm going to substitute it with what? My volume formula. I'm going to use the volume formula to substitute that. Because we're maximizing area or optimizing area, but I have a capacity that is in volumes. So I'm going to use this to substitute into here. So I know my volume is 1,000, so it'd be 1,000 divided by pi r squared is equal to the h. All right, since we're actually trying to maximize or optimize the area, we're in the deal of cost, right? Say yes.
Yes.
Because we're trying to do a cost analysis. So I somehow need to put in my cost of each item now.
Would you do it after?
No, I do it now. So because this is just area, we could maximize area all we want, but now we need it in terms of cost now though.
Oh, yeah. 'Cause
Yeah, so I have to include that into my equation. So the cost has to be going with this one. So now, this was the top, wasn't it? And what is the cost of the top? 5 cents per square centimeter, right? And so it's this, which is going to give me an area, right?
Yeah.
Times that cost. So my area, is going to be my cost, which is going to be 0.05 times 2 pi r squared, right? Plus. Now, the side material, size of the container, is 3 cents per. Then I have to put that in there. So it's going to be 3 That's a 2. Come on now. So now this is now in terms of cost because I had to put my cost in there. What else do I have to replace? Yeah, let's replace the H. So now, because I don't want the H over there, my area is equal to, multiply that, makes it a little bit easier, which would be 0.1, right? Pi r squared plus, I would have 0.06, yes? 06, right? Okay, that's going to be pi r times 1,000 divided by pi r squared. Did you work last night?
No, I haven't.
Oh, okay. Still. Okay, so I'm going to take this over to another page so we could actually do the math. So help me with this page after. So my area is equal to, was it 0.1 pi r squared, right? Plus,
Oh my god.
if you're awake, you might have actually got that. Okay,
I
so
feel like you did.
What? No. That scared me.
well, that's the most awake you've been all morning. So pi r squared. This one's not a square. This one's not a square. Okay, so clean it up. Okay, that's going to cancel one of the r's. So it's going to be plus point. That's not going to be 0.6. It's going to be 0.6 times 1,000.
This is 3 places. Left.
60. and over R. I said R, come on, R. So a lot of that just cleaned up. Yeah, I canceled one of the squares from the r squared from the bottom. Pi's canceled. So now go ahead and take my derivative. And when I do my derivative, I'm going to be maximizing my r value. So derivative, so dA dt is going to be, let me see, that's going to be 0.2 pi r, right? This is actually dA dr minus 60 over r squared. Okay, common denominator. So 0 equals, that's going to be r cubed. So 0.2 pi r cubed minus 60
Wait, why are we subtracting?
r squared. Huh?
Why are we subtracting?
My r's in the bottom, right? If it goes up, it becomes r to the negative 1, right?
Oh.
And when I take the derivative, it becomes minus, and on the bottom it becomes r squared. So, I'm sorry, I put a couple moves together right here. Alright, so let's go ahead and clean it up. So, set it equals 0, so the r squared goes away. So now I'm going to have 60 equals 0.2 pi r cubed. Divide by 0.2 pi, 0.2 pi. So, what's that going to be like? What do we come up with on that one?
942.478.
942?
Yeah.
942?
I think so.
60 divided by 0.2 pi?
Let me redo that.
Yeah, it should be 300 over pi, right?
Over 60 over 0.2 times pi, right?
95.49.
95.49? 49 what?
3.
Is equal to r cubed. And so when we take the cube root of that, so that's going to be the radius of the can. So if that's the radius of the can, that's going to maximize or minimize. And then to figure out the height, what would I do to figure out the height?
Plug in R into the volume.
Yeah, just plug in the R into my volume. Okay. All right. Like, share, subscribe.